Every day, around 83 million rolls of toilet paper are used around the world. It's one of the most essential items in our homes, but how is toilet paper made? We visited a paper factory to find out how toilet paper is produced. Toilet paper was developed in 1857 by American entrepreneur Joseph Gayeti, who launched it under the name therapeutic paper. Initially, it was sold in packs of pre-cut sheets, but in 1890, a major breakthrough occurred with the invention of the roll format, revolutionizing its use and making it more practical and accessible. It's estimated that each person uses about 100 rolls of toilet paper per year, which adds up to around 21 billion rolls worldwide annually. That's enough to circle the earth several times if unrolled. To reduce the cutting of trees, the industry heavily relies on recycling other papers. But transforming this used, rough paper into soft, white, absorbent toilet paper is a complex task that has been developed over the past 150 years. In this impressive paper factory, the production of high-quality toilet paper is done using an innovative recycling process that gives new life to discarded papers. This cycle begins with tons of paper arriving from schools, offices, and universities. Every sheet of paper that enters the plant goes through a meticulous sorting process where they distinguish between office papers, magazines, and newspapers that meet strict purity standards. Only those papers that shine for their whiteness and quality are selected to be part of this amazing transformation. These papers are high in fiber quality and are easy to process into soft toilet paper. Once the paper is collected and sorted, it is temporarily stored in large bales. The compacted bales allow large amounts of recycled paper to take up less space, making storage in the factory easier. Now it's time to start the transformation process. About 200 tons of paper are recycled daily. The recycled paper is fed into a machine called a pulper, which is a large industrial tank, like a giant blender, designed to mix water and recycled paper at high speed. This breaks the paper down into its basic fibers. A large amount of water added because the disintegration process requires the paper to be fully wetted to separate the fibers. Much more water than paper is used to create a watery mixture called pulp. Once the paper and water are in the pulper machine, rotating blades begin to stir the mixture with great force. This movement breaks the sheets of paper into tiny particles and releases the cellulose fibers that originally made up the paper. The agitation process lasts for about 10 minutes. As the paper is stirred and broken down, the cellulose fibers separate from each other, forming a fibrous liquid pulp. These fibers are long and flexible, which is essential for creating new sheets of paper. Once the paper has been turned into pulp, it's crucial to remove any impurities or unwanted materials that may have remained after the disintegration phase. The first cleaning method involves passing the pulp through a series of filters and sieves to remove larger particles that haven't broken down. These sieves work like strainers, separating impurities larger than the cellulose fibers. The liquid pulp passes through grids that catch larger objects like staples, pieces of plastic, glue, and other paper fragments, or materials that didn't dissolve properly during disintegration. Although the pulp has gone through several cleaning machines, it's still dark, mainly because its main contaminant ink hasn't been removed yet. One of the most common techniques for removing ink is flotation. In this process, air is introduced into the pulp, creating bubbles. Special chemical agents called surfactants are added to the pulp so that ink particles stick to the air bubbles. As the bubbles rise to the surface, they carry the ink particles with them, forming a foam that is then removed. Once the pulp is free of ink, it passes through a series of rollers that squeeze out excess water that absorb the bleaching chemicals. Then, rotating blades cut the pulp to prepare it for bleaching, where it's transformed from gray to white. The recycled cellulose pulp, now free of impurities and ink, still doesn't appear white. This is because the raw materials contain between 5% and 10% newspaper, which has lignin. To remove lignin, a chemical process called bleaching is required. This takes place in a large tank called a bleaching tower. Inside, The pulp stays in contact with a series of chemicals for a few minutes at controlled temperatures, resulting in the whiteness of toilet paper. To achieve the characteristic strength and softness of toilet paper, two types of virgin fibers are used: short fiber and long fiber. Short fiber, obtained from hardwoods, gives the toilet paper its brightness, whiteness, and softness. In contrast, long fiber, obtained from softwoods, provides strength to the paper. Next, the bleached pulp is spread over a plate that goes through a powerful dryer. Most of the water mixed with the fibers is removed, allowing the fibers to bond and form a solid sheet. In less than a second, the pulp becomes a thin sheet of paper only 1/10 of a millimeter thick. Once fully formed, it is wound into large rolls. These rolls are giant toilet paper rolls that haven't yet been cut into commercial sizes. Each produced roll can have up to 75 kilometers of paper. These large rolls will soon be reduced to thousands of small rolls, 10 centimeters wide, that we use in the bathroom. Once the paper sheet is wound into large mother rolls, they are transported to the conversion section of the factory, where several mechanical operations take place to cut the paper into small rolls. The first step in the conversion process is to unwind the mother rolls. These machines unwind the paper in a controlled manner, preparing it to be cut and processed into the smaller rolls we know as toilet paper. The toilet paper we generally use comes with perforation lines to make it easier to tear into convenient-sized sheets. This step is essential to ensure that users can tear off the sheets without difficulty. As the paper is unwound, it passes through a perforating machine that creates small regular indentations along the paper. The perforations allow the paper to easily separate into uniform-sized segments, typically between 10 and 12 centimeters in length per sheet. This pattern is not just decorative, it also makes the paper thicker and more absorbent. The embossing function gives the paper a raised texture. This helps give volume to the roll and, of course, adds softness to the sheets. Elsewhere in the factory, 80 centimeters wide cardboard sheets are created. These sheets are glued together diagonally to form a continuous cardboard tube, which is then cut into 165 centimeters long sections. These tubes are moved to the rolling area, where the paper rolls are combined to create two-ply toilet paper. The paper is rolled onto the cardboard tubes to form very wide rolls. Once a roll is complete, a blade automatically cuts it, and the process continues with the next tube. The roll's end is sealed with glue to prevent it from unrolling, and a circular saw cuts the roll into 16 standard rolls, each 10 centimeters wide. The toilet paper is now ready to be packaged. Rolls destined for commercial use are individually wrapped in paper, while rolls for household use are packaged in transparent plastic in packs of 4 to 30 units. And so, what was about 15 hours ago tons of used paper and cellulose fibers is now ready to re-enter society as toilet paper.